Okay, so we're going to do problem 13.4. I've already gone ahead and set it up in the interest of time so that the video doesn't go on for too long. Alright, so this is the question. There's a incline with a 45 kg mass sitting on it, and so the incline is angled at theta, let's say, and that angle is given indirectly through this kind of rise over run numbers. The coefficient of friction on this surface is 0.2. Okay? Now, drawing the equilibrium for these forces, finding the resultant for this, that gives us the acceleration. So this is the free body diagram for this block. Let's go it one by one. Okay. So first of all, we have the weight. Okay. Let's actually go ahead and erase this. So let's so first is the weight, which is mass times gravity. The mass is given 45, and here we have a component of that weight acting this way, which would be mg cosine theta, and a component of that weight acting this way, which is responsible for propelling this or sliding this block down. That would be mg sine theta. Now there is also a resultant force that will be acting from the block onto that surface, right? Let me do one thing. I'm going to show this here. Okay, I'm going to call this Fn, and I'm going to the weight acting on the weight of the portion of the weight acting on that surface, on this surface, that is mg cosine theta. Okay, I'm going to show that like that. Now, why mg cosine theta there? Let's go over to something that's let's do some geometry to find out. Okay, let's say this plank is inclined at theta, okay? And here is mg, just the weight of the body. Okay, now here is the both mg, the portion of, okay, here is the component. I'm just going to call this Fy, let's say. I'm going to call this Fy, and so this is the object, this is the block, so this is Fx. Okay, so basically we need to find this angle. Okay, what's that angle? If I were to complete this this triangle, if I were to complete this triangle, this is theta, this is 90, this is 90 minus theta, because then the sum of all of these is 180. Okay, so if this is 90 minus theta, now look at another triangle. Look at this big triangle, which I call ABC. In this triangle, this angle B is 90 degrees. Okay, right, because it's coming perpendicular to the surface, so this is 90. In this 90 degrees, if this is 90 minus theta, what is the rest? That should be theta, right? So that is why the angle between the weight acting vertically downwards and this reaction, reaction, which is in this case, what happened? So this reaction to this body is, that angle is between the weight and this these forces is theta. Okay, so just remember this because we're going to use this quite a bit in this chapter. Okay, going back here, so that angle is theta, right? So that is why this weight portion of this weight acting in this direction is mg cosine theta. Okay, so which, just for clarity, because it doesn't get, I didn't want it to get too cluttered here, I'm showing it here. Okay, I can go ahead and erase this. All right. What other forces are acting? There is frictional force. The body is sliding down, so the frictional force is acting here, which is mu k times Fn. There's no dot here. Okay. Now the body is accelerating down this way, right? So then the inertial force is acting this way. The inertial force ma is acting that way. Okay? And the acceleration is acting this way. Okay. Now it's just a case of simply doing sigma fx, sigma fy, and all of that. Okay, so let's do that. Let's first do sigma fy. Okay, and in this case, we're not saying we're not going this is y and this is x. We're not doing that in this case because the entire plank is inclined. So we'll do, this is x and this is y. Okay. So let's first do sigma fy is equal to 0. In this there are only two things, mg cosine theta and then fn. So if it goes down, I'm going to call that negative. So negative mg cosine theta plus fn is equal to 0. So the mass is 45 kgs times 9.81 cosine theta. Here we're not given theta, but we're given this in terms of the proportions of a triangle. So from this, if this is 5, this is 12, so the hypotenuse should be 13. So cosine theta would be 12 over 13. 12 over 13 equals Fn. So Fn is equal to, you get 407.08. Let me just double check that. 45 times 9.81 times 12 divided by 13 is 407.49. Sorry, not 08. 4 times 0.49, okay, Newton. Okay, that's the reaction force. Now doing sigma fx is equal to 0, what do we get? If it's going left, I'm going to call that negative. So the mg sine theta is negative, ma is positive, and the mu k fn is positive. Okay, so negative mg sine theta plus ma plus the frictional force, which is mu k times fn, is equal to 0. So negative 45 times 9.81 times sine theta is 5 over 13 plus 45 times acceleration plus 0.2, which is coefficient of friction, that's given. Fn is 407.49, that's equal to 0. Now all we need to do is find A. Okay, let's see what that comes to. Alright, so 45 9.81 times 5 divided by 12.2 times 407.49. Okay, I'm getting 102.149. Okay, let me make sure. Sorry, 5 over 12, 5 over 13. Okay, so I'm getting 88.29 as A. No, 88.29. 45A is 88.29. A is 88.29 divided by 45. That's 1.96 meters per second square.